Hello. This video is intended to address the concepts of central tendency and variability. It corresponds to Chapter 4 in your textbook. So, to begin with, we can talk about two different things when we're describing a set of data. These are descriptive statistics. The first is central tendency, and the second is variability. In central tendency, what we're talking about is a typical score. So we're trying to take a set of data and reduce it to a single score that describes that data set. And usually what we're using is either the mean, the median, or the mode. Those are all different measures of central tendency. They're a single number that summarizes that set of data in some way. Now, it doesn't tell the full story just to have an understanding of central tendency. We also need to have an understanding of how spread out the scores are. And that's a measure of variability. And there's a number of different ways that we can assess variability of a data set. And those include the range of the data. So how many scores does it encompass from highest to lowest? What's that spread like? The variance and the standard deviation. Now, in terms of central tendency, we have these three measures: the mean, the median, and the mode. The mean is probably one that you're most familiar with, as you've probably received information about what the class average was on an exam, for example. So that is the arithmetic average of all the numbers in a data set. And we use the formula m equals the sum of all the x's divided by n. This letter right here is the Greek capital letter sigma, and it is used in statistics to denote summation. So x is used to denote each individual score. So that's our symbol there. And n is used to say the number of observations in our data set. You can also think of it as the number of participants. If we wanted to calculate the average height, then we would sum all of the heights of individuals, and then we would divide it by the number of individuals in our sample, and we would get m, the mean. That's the symbol that denotes mean. We'll talk a little bit more about symbols in a minute. Now, for the median, what we're talking about is the middle score of a distribution of scores. You arrange the scores in an ascending or descending order, and you find the middle score. And finally, for the mode, that's the most common score, the score that happens the most. You can have distributions of scores in which there is more than one mode because more than one score appears the most. So eight number of times for both 21 and 40, for example. Okay, so the mean in symbols. What kind of number are we talking about? Well, we can talk about statistics or parameters. You might remember this a little bit from Chapter 1. Now, a statistic is used for samples, and a parameter is used for populations. So when we're talking about a sample, we're talking about a subset of a population, and we can calculate based on that data set the mean. Whereas for the population parameter, we're talking about all of the observations in a particular population. So the symbol used for a sample statistic with respect to the mean is either m or x bar. And of course, they're pronounced letter M or X bar, that bar over the top. Now, your textbook uses M, so I will be referring to the mean as M, but I might slip on occasion and say X bar, and so you'll know what I'm talking about. When we're talking about population parameters, now we get to use some Greek. This is the Greek letter mu, the lowercase Greek letter mu, and it is pronounced mu, like a kitten mews. And whenever we're talking about population parameters, you'll notice that all of the symbols we use are going to be in Greek. You might consider making yourself, taking a piece of notebook paper and making a chart where you have the sample statistics and the population parameters and what those symbols are. That might be helpful to have in terms of reference when you're working on homework and such, until you have these things memorized. Okay. So when we talk about central tendency, we can look at a histogram and kind of guess where we think that middle of the distribution is. And you can look at it in this distribution of scores. It's got to be somewhere between these two bars. So that's going to be our best guess. You can also think of it as a balancing point. You can calculate your mean to see whether that estimate is pretty close, and it is for these reaction times for the Stroop task. And again, here's that idea of the mean is kind of a balancing point of our distribution of scores. So you might want to pause for a moment here and check your learning. I have a set of data of student ages from statistics course, and I'd like you to find the mean, the median, and the mode. And if you're not sure how to go about calculating those, give it a try based on your reading of the textbook, and I'll walk you through the steps in a moment. So you might want to hit pause now and try and work through that. Okay, so now if we wanted to find the mean, we'll start there. We have our formula here, sum of all of the x scores divided by n. So x refers to this raw data. Each one of these scores is a single x. If we sum them all together, we get 399, and we have a total of 19 scores in our sample. So if we substitute in, you'll see 399 divided by 19, and that turns out to be a mean of 21. So the average age of students in the class is 21. If we're going to compute the median, the first thing we want to do is figure out how many scores do we have, and we already know that that number of scores is 19. And next, what we'll do to find the middle score, because we have an odd number of scores, there is actually a single middle score. So you take that number of observations, you divide it by 2, and then you add a half, because then it will give you what number, the nth score, is the middle score. So in this case, we have 19 divided by 2 plus a half, which would be 9.5 plus a half gives you 10. So the 10th score in this distribution of scores is the middle score. And so we can actually count up over here and find the middle score. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the middle score happens to be 21. And you'll see the symbol for median sometimes used in APA style as lowercase mdn. So our median and our mean happen to be the same. And lastly, the mode is the number that occurs the most. Now you'll see we have a long string of 20s here, and that number of 20s is 7. But let's check out and see, okay, so we have a chunk of 21s over here, there's 6, and then there's a couple more. So that's 8. So our mode also happens to be, in this case, 21. And I've made a frequency histogram here of all of the students' ages based on this data. And this would be where I kind of estimate, oh, this is probably where our balance point is. And here it's actually 21. So what do these values suggest about our data? Now, usually when you're looking at a set of data and the mean, the median, and the mode are all right there on top of each other, it suggests that you have normally distributed data. However, in this case, we have this one student who's way out here, age 27, and we can evaluate whether or not this individual is an outlier by looking at the standard deviation of our distribution of scores and determining whether or not it is beyond 3 standard deviations above the mean. And I've actually done the work for you, but I'm not going to go through all the complexities of getting a standard deviation at this point. But it turns out that this is an outlier, even though we still have all of these scores matched up. So it does suggest, just looking at this frequency distribution, which is why these are important, that there is a positive skew to our data just by this one single score. But the fact that we have so many people piled up here at the mean with so little variability, the effect of this outlier is pretty minimal. Okay, so the next question we might want to ask is, do these measures of central tendency capture the following slide adequately? If we looked at bipolar disorder and mood, we can see that there are a number of days where people tend to be depressed, where their moods are stable, and where their moods are high, when they're manic. And so even though we have a single mode of stable, it doesn't really accurately reflect our data because there are quite a few days where people tend to have depressed moods and where they have high moods. So we need to have an understanding of how these outliers affect central tendency. And what it really comes to is which type of central tendency is the best? Which one should we use? The mean, the median, or the mode? If you look at the mean, here's some batting averages, right? Everybody on the team except for this one guy who's really awesome. And the influence of this individual is to pull that mean in the direction of the positive skew, in the direction of the tail. And so the mean actually is influenced by outliers. If we removed this score and computed the mean, this is what we would find. That now our mean is 887.5, and it's considerably lower, and it actually is somewhere in the center of this set of data. So we have to be careful when we have scores that are outliers, or when we have a positively or negatively skewed distribution of scores, because it can influence the mean, and the mean is pulled in the direction of the tail. Okay, I'm just going to briefly introduce the concepts of measures of variability. If you want to see a step-by-step of how to calculate the standard deviation and the variance, there is a video available on Moodle about using Excel to compute those particular statistics. So the measures of variability that we have are the range, the variance, and the standard deviation. With the range, we take the lowest score to the highest score. So you take the highest score and you subtract the lowest score, and that gives you the range of data. The variance is the average squared deviation from the mean. So let me break down this formula for you. Here we have each individual x score, and we subtract the mean of the scores. We square that deviation from the mean, and then we sum each of those deviations. That value is then taken and divided by the number of observations, which is how we get averages anyway. And you'll notice that this is the sample statistic for variance, and it's denoted by SD squared. Okay, variance is the square of the standard deviation. The standard deviation takes that variability measure, the variance, and gives you a linear way of thinking about the variation from the sample mean. And so you could actually plot the standard deviation on a number line, and based on some things that we're going to talk about in upcoming chapters, you can talk about, well, what would we expect our means to be if we, or even our x values to be if we had sample that had this particular mean and was this variable. And so you'll notice that the only thing that's different here is that now we're talking about the standard deviation. It's not squared. And we take the square root of the variance. So again, we take each individual x score, we subtract out the mean, we square that deviation, then we add all of those squared deviations together, divide by the number of observations in the sample, and lastly take the square root of that number. It's really important here to remember that you need to square prior to summing. And the reason is that if you take each individual score and you subtract out the mean, because it's the arithmetic center of our particular set of scores, your deviations from the mean will be 0 if you don't square them first. That's why we have to square these scores. You can actually try that out with a set of data if you like. If you don't trust me on that one. So that's our basic overview of measures of variability and central tendency. And like I said, if you want the step-by-step, which I'm sure you do, of how to use these two formulas for variance and standard deviation, check out the video about using Excel to make those calculations.